Hey guys, my name is Ariella Yeager. You guys know me from the Digital Currency Index. And today for the March newsletter training, I'm going to be doing a small training on Hashgraph 101. Now I know that Hashgraph has been gaining attention lately, and I know some members have also brought it up, so we really thought that this would be a great bonus training for the March newsletter. I hope you guys enjoy the training and that it really expands your knowledge on the future of a decentralized economy. Before I get started, I do want to say that majority of this information that was found on the Hashgraph website, and this is strictly information that I spent a lot of time researching. This isn't, the views of the Digital Currency Index. This is strictly just information about Hashgraph, so you guys are educated on the topic. And I hope we can have really incredible discussion, conversations after this, and I'd be happy to discuss is all interested in this topic, do more research training. But yeah, we're just go ahead and get started learning about Hashgraph. So many of you have heard hash the future of blockchain, or I'm just going to take blockchain because of its super. In training, we're going to be learning Hashgraph, then the block. And you're also going to hear some advantages and disadvantages of the Hashgraph, kind of going to help you determine how hash play out in the future sector that we're in. So let's dive in. You guys can determine on your own if you think hash future of blockchain. You're bringing what is. And really Hashgraph, a new consensus system that provides better distributed consensus. Now for know what distributed is, we'll be speaking about later and kind of talking about. But Hashgraph offers benefits of the block and even technology, except data structure consensus claim graph is faster. Claim 200 plus transactions. Now, as Bitcoin does digits, it has mathematically proven fair consensus timestamping. Finally, they say that here, Hashgraph has bank grade, or that's also technically as anonymous but fault tolerant. Mouthful, but seeing here, Hashgraph is really the call with a distributed that's more fair and secure. Now, you're probably thinking that, as we always talk about with the blockchain, could be this. What does Hashgraph actually work? How does this happen? So whenever you research Hashgraph, this image pops up, and it's a cool image. This image would only think that, the best thing. This is a huge milestone ahead of blockchain. We still haven't even understood fully what block gotten massive. But it's really easier to understand what Hashgraph comes from here. And this is really just fixed about in Hashgraph. So here you can see an exact chain. It blocks being in this transaction, where then when you look at Hashgraph, you kind of see this web of transaction. And although in Hashgraph, these are called events and transaction. And I'll get into detail with that later. But it's essentially a graph. And these lines are graph. And these events, circles, full of hashes. So you're actually seeing a graph being created and this chain of blocks. And that's the easiest way to explain. And so for those of you that have, dug in blockchain or this tech standard, you know that hash like this distributed ledger, and that's what really advanced create the future of the distributed ledger. Solvability issues that I see. So I know it was kind of a mouthful, and that for some it hasn't really technology be blockchain. They're not stand. So let's just get into this a little. You know this is just repetitive. That's okay. It's all good to continuously keep going. So as you can see, this is centralized. This is a North company institution looks like. This is kind of what getting away from. And that's centralized, which we've all talked about. And then is this not as a little bit of these webs coming off a centralized point. Really decentralized, apart from each other. Then we have. And distributed is really this, and everything is completely distributed by different people. You never location, and it's even completely distributed. And so, in the beginning, when I said that graph, what a new algorithm ledger technology, that's essentially this. And so off this, there are, platforms that are used, but they're not using distributed. And this is an advancement to right now. And to understand it, you really have to stand, and so before details about how it was created. And so is actually a company, and they building of distributed applications focused on the development of application on the Hashgraph. Lehman Bear, see on the left, is really the brains behind it. He's the one that invented it. Mance Harmon, who's the CEO, if you really go to the website, as source on here, rounds are really extremely impressive. Lehman Bear has the fastest PhD at Carnegie, but they're incredible. And so if you really want, you can. And they've landed millions of dollars in funding to Graph and actually officially launched 15th. If you're watching this video, released the newsletter that Saturday, officially launching in New York. And I find extremely exciting. Things to keep in mind when we're moving training is that their tech is currently working. People can, and it has been mathematically proven that it is fair and fair. Doing an I don't need funding to get this tech off the ground. It's actually working. The software is in. And last year at CES, held a hackathon where people could off the hash graph and create their own centralized or things. And people built with 24 hours, in a World of War video game. This technology was pretty incredible, and it really showed, you can build off of it. It's not that difficult. A bit of kind of a background into the company, that there's people. Let's go into the nitty-gritty details. And in order for these details, you really have to understand compares to the rest of the market. Now in blockchain, different way of doing this. We have proof of work, proof of stake, also many more other ways to go about things. But I'm really going to talk about today and kind of to the hash is proof of work. To do this because this is what majority are using right now. In Bitcoin, we're currently using proof of work. Ethereum and other projects will move to. This is still the industry standard in what I thought it'd be a really to explain. So, this kind of what explains the work method. I made this little diagram, and it's it's great, but it kind of allows. And this works when users submit transaction. And from there, network, miners, and select all the transactions, and then they what transaction to a block, and what order that happens. And the miner complete the opportunity, P solve a cryptographic puzzle in order to publish block to the network. Does win that cryptographic puzzle, publish that block, and the key accepts it on the blockchain. And this makes the system slow. It takes time for miners to come to an agreement on what to put on the chain, and it's a little unfair because the miner that wins, they can influence which in the transactions, which can set fair and kind of this issue because I'm bribed or whatnot. So it's this slow and this, this unfairness. But let's dig a little deeper under, what's happening here. And how graph compare? Hash graph to gossip protocol. Protocol is a well-known term, and it can be defined any random node and tell everything you know and don't know. Kind of like the chatting in your office, wildfire. This graph here really explains this gossip to gossip pro like with the hash. As you can see, it's constantly being gossip to different users. But let's truly what that movie graphic is showing and the information that it's sharing to users. So let's look at this first image they have here. This is exactly talking about. You have these lines right here, and you have these search and information, essentially creating a hash graph. And you can also see 4 full nodes here, A, B, C. And the purpose of training, I'm going to first, and each member start creating an event, which that you see. This here is called an event. So it is essential or multiple transactions. Higher goal hash graph is for memberity to come to consensus on the order of events, agree to a stamp for without letting attackers or to utterly influence these, just like we saw in proof of work. So let's look at when the gossip protocol begins, and what we see that Bob down here, we see that Bob ran to call Mem D, let's call it. So Bob randomly chose, and I want you to pay attention that all these messages are completely at random to your neighbor. They're random nodes and networks. It can be manipulated. Dave receives this message, towards this is happening, information, Dave's him, and he go event, we hear this new search actually created by Dave. And starting to see this graph or members communicating to each other in a manner. But let's event and what it really means. The information inside this event is shown here. In every, you have the time, and actually the time in the way it creates is there take the media timestamp events surrounding it. I'm, Node or Bob, and I'm sending this information to Dave. I can't manipulate the time I'm sending it. It's next year or a year ago. I take the media of events around it to that timestamp is. And then you have the transaction, and then you have the specific event, and it hashes. It has the hash of Bob, and it has the hash from Dave of this event. You can see there's 2 going, 1, 2, and that is those 2 hashes coming. And Dave sees this information, and there's these 2 hashes, and he's the timestamp, Dave sends all this information. He duly signs it, the event is zipped, and put hash graph into a new event. Dave created with this and by guiding it. Even though this such a complex process, this is happening times in a single second, which is incredible. So now that we can understand hash graph and we can see, right here, went through this, and we can see that it has now sent information, famously back to Bob. And then what we see is when I'm sending info, I'm also the last person I talk to. It's this interconnectedness of info not be hacked. Make sure one single person can ever network. So here we would see that things happen. We have 1, we have 2, 3. And essentially, it's how we get here earlier. And I love this graph and really see everything we talked about in the continues. Every event circles the hashes of events below, and it's digitally signed by its creator. So the hashes, cryptographic arrow, but the other parts are immutable and as strong as the cryptographic hash signature system, and it just continuously goes upward, just like the graphic is showing you. So I know that that's a lot and I know that quickly. And you can always rewatch this video and do your search. Take a breath. I know the information, but you got through. Actually start to through this information, dig into it. It's really not as complex as you would think it is. Now, I showed this transfer of information, how they gossip protocol, and I showed you what information is, timestamp, attraction, but there's one thing that's missing, and so I'm going to dig just a little deeper into how so you understand this, and I promise I won't get to in this part quick. So, we all understand how the information is spread, but how did the order of transactions, like how miners come to consensus that this year? Well, Hashgraph uses virtual voting, and virtual voting for over 30 years. It actually has fantastic security properties. The problem that with virtual voting, it requires extreme amount of bandwidth. That makes it really inefficient, and that's why it's adopted by. But Hashgraph, all voting comes, but they never can single vote. Thinking how that works, that kind of really seems. But do this by using Gossip Protocol talked about. So all the transactions are happening. They have to get gossip, and you kind of saw that web that was created. Everybody getting the and it's kind of web. And so virtual voting, minimum baseline for the algorithm that you have gossip information. Hashgraph decided to a small portion more information. And so I'm going to an example to explain it. So an example is if you were a transaction to somebody, you always would include the transaction and the event, but inside that you would include a very small portion of information of who you last, which node you interact. This happens with every, and what this creates is a graph of the hash that shows who talked to who and when talked to that. And this, nobody has to cast a vote because they can information and they take all of that and they calculate internally exactly what each member vote if cast the vote, because the information go out and which way would you vote, which order, because they already know how they would communicate, already know how they vote without ever having, because of this to gossip. And so they calculate this, it's essential about gossip, builds up the hash, and it builds it up to determine the order in which the virtual voting should happen. They created virtual voting, and it creates this autonomous voting of which transaction should occur in order. And what this is, this 100 transactions per second, some pretty amazing security benefits to be Hashgraph, which is really pretty amazing. That's for you today. I want to say congrats. I'm going to talk about, so don't leave quite yet. You stuck. Congratulations. This is a pretty technical topic, and that it took years for me to, training into where I'm at. But definitely more of a complex system. It's something that we'll be talking about. One of the biggest things that I always hear people talking about with the blockchain is speed, scalability, and that's what everyone complains about when they see speed, scalability, and safety. Look at the hash; they're solving all of them. Their technology is already. They have already built some incredible things on the system, but there's still advantages with Hashgraph. It's not all sunrose, and that this technology is just overtaken. So what I want to about some of those advantages and what we learned, so you guys can really get a recap. So in review, we learned Hashgraph consensus for distributed technology here, web of transactions, okay? And they also use the call to send and receive and that's how we got web. They use voting to determine the order by a piece of information of the node you talk to, so they have a database, because they already know, and faster, have clarity, more fair for their users. Now, very beginning of this I talked about Worlds, which was that created Hash, and talked about created it in the of that company, patented technology. And this makes centralized a little weary because a patent essentially makes the company hasn't their software yet, and it allows very specific members to use build off of it. You can go online, you apply, you have to be vetted in order to become one of the developers. But kind of against the spirit centralized, it's really a monopoly of technology, and that kind of people in the community that are looking at Hashgraph chain a little upset with how. So when you're thinking, will this really take over blockchain being open, it's kind of that. But I really soon to tell. The technology is to be working out